This is video 16 for College Algebra. We're going to be looking at dividing polynomials, and we're going to be using long division and synthetic division to do so. So first of all, let's take a trip back to elementary school when we did long division. So remember, if we were doing this, we'd see how many times can 7 go into 4. Well, we can't do that, so we'll try how many times can 7 go into 47, which would be 6 times. So we take 7 times 6, which is 42, and then we subtract. So then we're left with 59. And we see how many times is 59? Does 7 go into 59? Well, that would be 8. So we'd have 56, and we'd subtract, and we'd be left with 3. And that would be our remainder. So our answer for this would be 68 and 3/7. Well, we're going to be doing the same thing, but this time it will be with polynomials. So taking a look at our first example, so we've got this big long polynomial. We first need to find a 0 of this polynomial. So in your graphing calculator or on Desmos, we can type in our equation. And take a look at our graph. All right, and so we can see that it crosses, it looks like, in 2 different spots. So if we look at our table of values, I can see that at 2, I have a 0 or a solution. All right, so from there, and we can kind of, from this, we can kind of graph what this kind of looks like. So we have a 0 at 2, and at 1, it's at -1, and our graph kind of looks something like this. All right, so we can use the fact that we know that 2 is a 0 to find all of our remaining zeros. So we know we have a 0 at x equals 2, and we're going to use that to find our remaining factors. So if there's a 0 at x equals 2, I know that my factor for that 0 is x minus 2. So it's kind of like I'm working backwards. And so then we can use that factor to find our remaining zeros. So we are going to divide the rest of our polynomial by x minus 2. So with long division, we are going to first start by seeing how many times can x go into 6x cubed. So essentially we're thinking x times what will give me 6x cubed. So that'd be 6x squared. So then if I take 6x squared times x, it should equal 6x cubed. And then I'll take my 6x squared and multiply it by -2. That would give me -12x squared. Now I subtract my entire polynomial that I just wrote. So I subtract that. So that would mean I distribute that negative, and these two would cancel out, and this would become minus a -12, which equals -7x squared. And then we drop down our next term. So now, x times what will give me -7x squared? Well, that would be -7x. So we want to find what will create that first term. All right, and now I subtract my entire polynomial. Those are going to cancel out. This becomes a minus, and I am left with 2x. And then I will drop down my minus 4. So x times what is 2x? That would be 2. And I would be left with, after I subtract all of these, okay, I'm left with 0, which we should get a remainder of 0 because we already know that x minus 2 is a factor. And now we're going to look at our answer, and we're going to find our remaining zeros from there. So if we think about it, we've got x minus 2 times 6x squared minus 7x plus 2. That is our original equation that we started with. Okay, then we can factor my 6x squared minus 7x plus 2. Okay, after we factor that, so we'd think what multiplies to 12 and adds to negative 7, and then we would reduce our factors. And so from here we put each one of our factors equal to 0 because we are solving for our zeros. So I've got x equals 2, which we already know that's a 0. We've got x equals 2/3, and x equals 1/2. Okay, and so we can kind of check some things. We needed to have 3 zeros because we started with a cubic function, so that means we need 3 zeros. And we've got our 3 zeros. And then of course we can always look back on Desmos or our graphing calculators and double check all of our work. So that's our long division. Let's do another long division problem. Here it's just a strict problem. So let's rewrite this. Now, if we jump from exponents, here I've got an x cubed and then it goes just to x. We need to put placeholders in. So I would say plus 0x squared. So it has to be in standard form, and we cannot forget any exponents. So starting off, 2x times what will give me 4x cubed? Well, that would be 2x squared. And so now we're going to take our 2x and multiply it by the 2x squared, and then we'll take our 5 and multiply it by 2x squared. So I have 4x cubed plus 10x squared. Let's subtract this entire row, and our 4x cubes will cancel out. If our first term does not cancel out, then we've done something wrong. Okay, and then you'll need to check your work again. So I've got negative 10x squared, and we're going to drop down our minus 13x. Now, negative 5x times 2x will be negative 10x squared. Okay, and then we just subtract again. Now, when we subtract negatives, those change to positives and they will cancel out. So I've got 12x, and then we drop down our 20. So now we've got plus 6, and that would give me 12x plus 30 when I subtract this, I'm going to be left with 10. That is my remainder. All right, and that is what is left over. So this is not a 0 because, or it's not a root because we did not get a remainder of 0. In order for something to be a solution or a root, it has to divide evenly. So we would add plus 10 over 2x plus 5. Oh, I'm sorry, that is a minus. So that will be a minus 10 over 2x plus 5. All right, so that's the biggest thing. Something is a factor if the remainder is 0. All right, synthetic division. This one is kind of fun. It only works, though, when your binomial has a leading coefficient of 1. So, for example, we wouldn't have been able to do it with this because this was a 2x and not just 1x. So when we start with this, we take the opposite of what we're dividing by. So since we're dividing by an x minus 4, we're going to put a positive 4 inside that box. And then we will write all of our coefficients in order. So we've got 1, -6, 11, and -6. And then I like to leave a space, and then I draw a line. And then always we drop down that first number. Okay, so just another reminder, make sure that 4 is always the opposite of your factor. All right, so starting off, we take our 4 and we're going to multiply it by our 1. When we get that, we write that underneath the next. So we've kind of got a lot of arrows going on. And then we add. So you always add going down. So -6 plus 4 is -2. All right, and so now I multiply 4 times -2, which is -8, so I multiply and go this way. And then I add going down. So then we would have 3. And then I multiply 4 times 3, which is 12. So again, we multiply and then add going down. And this would be 6. And that is, you put a box around that because that is your remainder. So the last thing you always put a box around, and that's what your remainder is. And it just kind of helps keep it clear that that's not part of our equation. It's not part of our whole number answers. It's our remainder. So when we write our answer, these are all coefficients of our polynomial after we divide. Now, since we're dividing by something with just an x, our answer will have one last exponent in it. So the degree will drop by 1. So here I would have x squared minus 2x plus 3 plus, and then we add our remainder, 6 over x minus 4. So all of my exponents drop by 1. If my highest exponent is a 3, my answer, the highest exponent can be a 2. All right, so let's do one more example, and then we'll be done. So here I'm dividing by a x minus 3, so in my box I put a positive 3. My coefficients, 2, -7, I need to put a 0 in for that that plus 0x, and then minus 4. Leave a space and draw your line. So we drop down our first number, which is 2. 2 times 6, or I'm sorry, 2 times 3, which is 6. So we multiply, and then we add. All right, 3 times negative 1 is negative 3, and then we add. 3 times 3 is negative 9, and then we add. So my highest exponent here is a 3, so my highest exponent and my answer will be a 2. So I've got 2x squared minus 1x minus 3 minus 13 over x minus 3. Now we don't have to put that negative 1x, but I just wanted to show how this translates. So in the most simplified form, this is how we would write our answer. All right, so I know this is kind of a long video, but synthetic division and long division are some pretty complicated things. So make sure you're practicing these, and this is dividing polynomials.